Hey everyone, I'm Leland. Some of you already know me, but we're going to go over the 14 different types of LeetCode problems. So I saw this really interesting video, and apparently all LeetCode problems can be broken down into one of 14 categories. Today, we're going to be doing the very first one, which is the sliding window. So the sliding window basically works as taking in a bunch of iteratables, either a string or an array, and it takes in the length of a window that you're going to be looking at and the target value that you want to meet, whether that is a sum or an average or a product or whatever it is. And some things to note is that window size might change, but it's usually held as a constant, and the target value or threshold might change as well. So what does this look like? And this is the LeetCode problem that we're actually going to be going over. You should have a link to it in the chat. But given an array of integers, ARR, and two integers, K and threshold, return the number of subarrays of size K and average greater than or equal to threshold. And this constant num sub arrays is the function, what it'll look like. It'll take in an array, it'll take in the size of the window, which is K, and it'll take in the threshold, which is the value that you want to return, which is the average, which is the average greater than or equal to threshold, right? So that'll be some number. So we have two examples that we look at in our LeetCode problem. One is with this array, 222 to 5558, with a window size of 3, or a subarray of 3, and a threshold of 4. And the output is 3 because there are 3 subarrays, 255, 555, and 558, that have averages of 4, 5, and 6 respectively, all of which are greater than or equal to our threshold. And in the second example, our window size stays the same, but our threshold changes, right? And so there are 6 arrays within that window size of 3 that have averages greater than or equal to 5. So let's start with the very first window that we're looking at. Our window size is 3, and our first 3 values are 222, right? So here's our input array, and we can see we're going to put a pointer on 2 and a pointer on 2, right? The first index and the third number in our array, right? And remember, our K is our window size of 3. If it were greater than 3, we would stretch our window further. So this is what our window looks like. Again, it's an array of 222. The sum of those numbers is 6. The average is the sum divided by the length of that array, which is 2. And we see that the average is less than the threshold because the average is 2 and the threshold in our example was 4. Right? So we don't do anything to it. Next, we go to 1. And in 1, we just move it over. Same thing. We see sum is 6, average is 2, do nothing, right? Now we go to 225, right? And by now, I'm sure you're starting to see a pattern, right? So now we have 9 and 3. And now we are finally at our third index, where we finally have a value that exceeds or equals to our threshold. So once this happens, we're going to do something to the value, right? However you want to store it, that is your prerogative. However, just bear in mind that this is the point where you have to log or store your value, right? Because now your sum has exceeded or equal to the threshold. So we move on. We have 555, which is 15, right? And divide by 3 is 5. So we're going to log that one too. We're going to log this one too. Now, in this example, the array is sorted, right? So it's very easy to kind of move through the array. But if we go backwards, right, to our other example, we see that this array is not sorted. So you cannot count on the array being sorted, right? You can sort it if you'd like to, but that does add time complexity to your problem. And you can solve this problem in O of n time. So we're going to take some time now, where apparently I do not have a timer on here. So we're going to take 30 minutes, and we're going to solve the problem